Last time, we see that intersection is a vector space, subspace, but unfortunately, union of subspace is not a vector space, so it is not a subspace. So, we will define today the sum of subspaces. So, we also have a same notation. This is K vector space. And U1 and U2 are subspace of V. Then we will define U1 plus U2. U1 plus U2 is nothing but just set whose element is sum of everything U1 plus U2, where U1 in U1 and U2 is in U2. Of course, this is in U1 union. Okay, yeah. And this is of course subset of V. So this is a set which can be written as some sum of U1, element of U1 and U2. This is called sum of two subspaces, and because it is include all the closed all the summation, now it is a vector. And also because we include every U1 and every U2 in U1 and U2 by choosing U1 equals 0 or U2 equals 0. So this U1 plus U2 contains U1 union U2. So as a set, it contains U1 and U1 union U2. And moreover, maybe it can be equal when U1 is a subset of U2. But anyway, U1 plus U2 is a subset of V. The question is now, okay, because this plus might confuse you, I'll write V under this to say it is different. So maybe I'll write plus here. So let me go again. This U1 plus U2 is a subset of V. Then you might want to check U1 plus U2, this set with the plus defined with V, and S multiplication defined with V. Is this a K vector space? The answer is yes. I'll not explain much. You can just check closure because it contains U1 union U2. So everything, identity and inverse is already here. And also, you close operation by including every element. So everything in U1 plus U2 goes to U1 plus U2 with the addition and S multiplication. If you want, you can check. So this is just sum of subspace is just extending subspace to make it vector space. With the figure, you might understand more easily. Let us assume a plane R2. In plane, you can have one subspace R1, R, which is on this line. So if this is 0, you can add everything. This one, every, okay, let's go arrow, maybe. So you can assume every arrow here. This is some subspace. And you can assume some other. It doesn't need to be perpendicular. Other, including also 0. And this one is also vector space. In every line, you can have any summation and S multiplication here, blue line. And the problem in the union is that if you add some plus this one and plus this one, then if you have this multiplication addition rule, so then you will have some random thingy which is not in this one, which is not in this line, some on this plane. So this is not closed. It was the problem of making union, but now plus contains all the space because it is just telling all the set including which can be written in plus. So it is just again the whole space. So this is vector space, and it is vector space, so it is also subspace of V. So now you have sum of vector space, subspace to make vector space, and also there is a name called direct sum. It is nothing. It is u1 plus u2, but u1 and u2 are disjoint. Disjoint. So in some people write, so to emphasize it, you have this O plus sign. So O plus sign for direct sum, and this is defined u1 plus u2 in V such that u1 in u1, u2 in u2, and maybe I write and, logical and you can use comma also, but I prefer u1 intersection u2 is why I write, I don't know, empty set, so it is a disjoint. So everything we can write in this form, u1 and vector of u1 and u2 summation with the disjoint, then it is called direct sum, and direct sum is shown denoted with this O plus sign.